Hi everyone, my name is Brian. My topic is the first memory pooling solutions. And this is the first CXL switch attached memory solutions. So before I talk in my presentation, I'll talk about a little bit of background of S3 platform. We have been developed a PCI fabric switch starting from 2017. So including PCI Gen 3, Gen 4, and Gen 5. So we know very well so-called fabric managers and device peer-to-peer transactions. So of course, as you know, the CXL device management is leveraged from PCI switch. So we know how we build the CXL memory poolings. So today's topic will be, the first I will talk about hardware, so the hardware architecture, how it being connected. Then talk about the software features, how the memory being composed. And then, of course, we'll use a GUI to explain what the information we will provide to the user. And then you understand how you can look from a host point of view and or from device point of view, how you see the memory pooling solutions. And then we will talk about fabric management features. And then the most important that we have the very first systems working, and we will show you the result of Intel MLC test. On the middle, this is a physical rack. So there's some compute nodes as a host. And then there's a memory appliance. So all the 6 memories, of course, in the memory appliance. When the 6 memory being assigned to the host, then we will become a logic view. So the host will access the 6 memories as its own NUMA node memory. So what we develop in this system is that we provide a memory pool appliance and also the fabric manager, so that to manage the whole memory pooling solution. This is a solution that we developed. So there is a one SCON CXL switch. It's a 256 LAN. So it's been configured as a 15 by 16 port. And each port, of course, is a Gen 5 by 16. And then there is a one MCPU. The management MCPU is do 2 things. First is to do, of course, all the configuration of the memory modules. And then they put all the software stack, including the GUI, the GUI and the APIs in that MCPU board, and to provide an API to the cloud orchestrations integration. So the software stack that we built into that MCPU is that on the left buttons, you see this CXL switch management, including like port configurations. You can configure port as a device port or host ports. Of course, when you change the port from the host ports or to device port or from device port to host port, you need to regenerate all the PCI tree architectures. So you need to reboot the systems. On the right side, we integrate also the CXL module solutions. So into our daemon 1. So this daemon 1 is mainly for all the CXL memory managements. And then the daemon 2 is that for the chassis management. And then on top of that, we provide a RESTful API. This RESTful API is for the orchestration integrations. So you know normally they have central orchestrations to ask which memory be assigned to which host. And then we, based on their request, to do that kind of operation. So the features-wise that we provide is that we can assign the specific memories to the host. You can assign the whole memory module or just part of the CXL memory. And of course, that we say it's a small memory chunk. It's within one CXL memory. So you can partition the memories as a small memory. So we call it memory chunk. You can slice into the small memory chunk. Then we build up the memory mapping from the device to the host. So that is a DLUT lookup table. So if we build the 2 mappings, so it means that physically one memory chunk been assigned to 2 hosts. So create a memory sharing architecture. And then we can configure all the ports as a device port or host port. Then we also read all the registers of performance registers and present all the different slot performance. So you have all the ingress and the egress performance of a single slot. So you have a better understanding what's going on for all the CXL memory modules over the host ports performance. This is the GUI. So in this GUI, there's 4 different hosts and 11 devices. So when you click in the host, then you will have the host overview of all the hosts, what they see. For example, on this side, this is a memory chunk has been assigned to the host. And this is a memory chunk. It's been available to assign to the host. I think the important thing is that, as I mentioned, that we can share the memory. So if we mark as a shared memory chunk, it means that it could be assigned to multiple hosts, that multiple hosts read the same physical memory chunk. And on the top is the memory host memory address. Like this host 1 memory address. It's been reserved from 8 terabyte to 9 terabyte. And you can see which memory chunk been mapping to which memory sections in that memory address. So that is the host view that you can see all the information that we provide to the API and to the GUI. In this memory chassis, in fact, is self-contained. What's mean that self-contained? Because these chassis should manage the memory by themselves, should manage the chassis by themselves. So it provides 3 different functions. First one is, of course, the memory management, how to cut into the small chunk, how to do the mapping from the memory to the host. This is the first configuration. The second part is very important because you need to have all the management features, such as the each port performance and how many memory chunk you have and which memory chunk will be assigned to the host. So you should maintain a kind of a database of the host to the memory mapping. So this is the second part, the management features. And that is, then the third part is that if there is something wrong for that chassis, you will send out the event log to like central log servers or to integrate with some of the cloud's central log management service. So for these 3 features, we build into in our MCPU, and we will use open fabric management framework to provide that kind of information. And of course, then we will integrate with the main verge usage information. So we provide this kind of information. They will have better understanding what's going on the whole chassis, and they can easily, based on that kind of management information, to assign the right memory to the right host. Okay. So this is a testing setup. We use in the memory pooling solution, there is a SCON switch, and there is a management CPU. So the management CPU will configure as the host port or device port, and then he will build up the mapping of the CXL memories. We use a Samsung CXL memory as a montage controllers to be assigned to the host. So when it be assigned to the host, the DLUT lookup table will be built. So when the host scan it, he will see there is an endpoint here. He will use this memory address as its NUMA node memory. So the server that we use is Intel Software Rapids servers. And the memory is, as I mentioned, is Samsung. Then OS, the most important is that we use a Linux kernel 6.2. This is the kernel that we are using. And we use the MLC versions 3.1. This is all the testing information. So the result that we got is that this is MLC. There's a node 2. You can see that node 2 is, in fact, is the CXL memory modules. So node 0 is the first CPU, that node 1 is the second CPU. So the CXL memory module is attached to the node 0 because you see as the node 0 as the closed memory, and then node 1 sees as far memory. This is the result we got. In the DDR, it's 120 nanoseconds. CXL direct attached, if we direct attach to this 260, and the CXL switch attached is 500. So it's a closed node, but in the far node, it's around like 743 nanoseconds. So I think everybody knows it's not as expected. But because this is the very first systems, I think everybody understand that in the CXL controllers, CXL switch or retimer are in the engineering sample. So it's going to productions very soon in the Q4, all these three. So we can get a much better numbers. At least that we expect it should be within like 400 or even 350 nanoseconds for the closed node, and like 420 in the far node. Okay, and then we are going to do the latency breakdown in our next testings, because this is going to involve testing and the development. So we will keep doing the pulling and the sharing result in the coming months. Okay, so we are looking for, if you are interested in kind of collaborations for the system solutions or for the hardware solutions, it's very welcome to come to us. So thank you very much for listening.